Okay, so this is unit 3.3, so I'm going to run through the answers to this unit now. First off then, describe how you'd sample water from a stream. Take a sample from where the water is moving well, collect the bottle and sample 1 or 2 centimetres below the surface, fill the sample bottle to the top of the stopper. Describe how you'd sample from a tap. Disinfect the faucets, the end bit of the tap with bleach or a flame. Run the water several minutes to clear the line. Take a sample midstream, okay, so not right at the top, not right at the bottom. Do not touch the sides of the collecting bottle, the opening or inside of the cap. If needed, because you can't take it to wherever you need to go, store it in the refrigerator before taking it to the lab. So qualitative analysis means only identifying substances, okay? So it's often word answers is how we would consider that. Qualitative then gives the concentration, so numbers. And then semi-qualitative gives a rough concentration, a bit like you looking at fields and saying I can see 10 daisies, but not being 100% that you can see 10 because you're just making a rough estimate. Okay. Next kind of thing that's really important in unit 3.3 is being able to identify how you would identify compounds. So you've got copper chloride. You would do a flame test, which would give you copper, which would be green. You would then do a silver nitrate test, which would give you chloride, white precipitate. Okay. Barium then again is a flame test, apple green. Carbonate, lime water turns cloudy. Iron is add sodium hydroxide and it will give you green precipitate. Bromide, silver nitrate test, green precipitate. Lead, again, NaOH will give you a white precipitate. Carbonate, lime water turns cloudy. Calcium then, flame test, brick red. Barium chloride, white precipitate. Okay. What is the stationary phase and the mobile phase? Stationary phase is when it's in liquid. Mobile phase is when it's a gas. How do you calculate RF? RF is the distance travelled by the substance divided by the distance travelled by the solvent. Okay. So the distance travelled by the substance would be like that. So imagine it was 3. Then the distance travelled by the solvent would be all the way up there, which would be 10. Okay, so it would be 3 divided by 10, which would give you 0.3. Okay. What factors affect the retention time, distance and temperature? Which samples make German silver? Okay, so draw lines across from all the points in German silver. So it's copper, nickel and zinc. Okay. What is the ionic formula of potassium carbonate? So you do top, swap, drop. Okay. Okay, like that, you don't need the 1. Molecular mass then, do the table. So you've got 2 sodiums times by 23, which is the massive number. 1 carbon, 3 oxygens, total 106. And then moles would be the mass, which they said was 1.6, divided by the MR, which would then give you 0.01 moles. This then is the second part of unit 3.3. Again, that's the sheet that you should have, and I'm going to run through the answers. First off, describing the pH scale, a series of measurements which allow us to identify if something is acidic or basic. What is the equation for working out concentration? So moles equals conc times volume. So concentration would moles divided by volume. What do acids contain? H plus ions. What do alkalis contain? OH minus ions. What is the equation for neutralization? Acid plus a base equals salt plus water. Name the following salts, okay? So the first name always comes from the one that isn't the acid, okay? So you've got 2 things. That is the acid, this one isn't. So the first name is going to be copper, okay? Hydrochloric acid then is chloride plus water because it's oxide, okay? Same kind of thing then. That's the acid, so it's going to be nitrate. Sodium's the first name, carbon dioxide plus water, okay? Potassium then plus sulfuric acid will give you potassium sulfate plus water, okay? That actually should be plus hydrogen. And then this one, lithium hydroxide plus sulfuric acid, will give you lithium sulfate plus water. Describe DNA. So I put A binds with T, G binds with C. It's a sugar phosphate backbone and it's a double helix. What is genetic profiling? Separating DNA into pieces for analysis. Advantages, you can work out paternity, criminals at a crime scene. Disadvantages could be an invasion of privacy, especially if we store it somewhere, so it's on a database then for everyone to see. DNA profiles to determine paternity. So this baby then has father. Okay, it has father A. Okay, its father is A. The reason for that is you can see this one here. If this is definitely its mother, its band need to come from its mother and its father. And that the mother doesn't have the one at 8, but father A does and father B doesn't, so it has to be father A. Up here then, describe the method of chromatography, okay. Simple chromatography is carried on paper. A spot of the mixture is placed near the bottom of a piece of chromatography paper. The paper is then placed upright in a suitable solvent, such as water. The solvent soaks up the paper, it carries the mixtures with it. Different compounds of mixture will move at different rates, okay. Really then long method for titration. There are other videos to watch on titration, so I'm just going to leave that, pause it, so you make sure that you've got your method for titration in. And then what is colorimetry? Colorimetry is able to measure light absorption, how much light is absorbed, or light transmission, how much light passes through a substance.